Dear friends and followers, welcome back to my channel and lovely greetings from the Ottersberg VOR close to Munich airport. Today's video is very much addressed to my flight students as we'll be looking at the question, what is a VOR, how does it work, and what a VOR has to do with a lighthouse. You'll need pen and paper for this one, so let's get started.
Market 236, Kennedy ground, shoot your right, go right on Bravo and hold short of Victor. Right on Bravo, hold short of Victor for shoot your right, Market 236.
Today's video is brought to you by Captain Joe's Fan Shop. Stand out as an aviator in one of our great t-shirt designs. Click the link in the description box to get yours today. Happy shopping!
If you already know what a VOR is, etc., and you want to learn how to determine your position relative to the VOR, there's another video coming out next week. VOR stands for VHF Omnidirectional Range. I know I haven't made it any better. VHF stands for Very High Frequency, which makes a VOR only a short-range radio navigation system. So in line of sight, VORs are only receivable from 25 nautical miles up to 140 nautical miles usable radius. And line of sight meaning if there's a mountain between you and the VOR, you will not receive a reliable signal even though you are within the station range. Omnidirectional comes from the Latin word omni, which means all or every direction, meaning the VOR sends out 360 lines, let's call them lines for now, which can be picked up by a VOR receiver. And in today's video we'll use a CDI, a course deviation indicator with an OBS, a Omni bearing selector, which is very common in your standard Cessna, Pipers, etc. Now on your VFR or IFR chart, this big ring with a symbol in the middle indicates a VOR. It comes in three different types. Now this one represents just a VOR, like the Southampton VOR on the south coast of England. This here is a VOR DME, so a VOR with a distance measuring equipment showing you how far away you are from the tuned in VOR, like this one right behind me. And last but not least, you have the VOR TACAN symbol. TACAN stands for Tactical Air Navigation. The most famous one in Germany is probably Tango VOR south of Stuttgart Airport. Next to the VOR symbol, you have this box. Now the top line states the name of the VOR. So the VOR you see in the background is Ottersberg, south of Munich Airport. Below that is the VOR frequency, which can only range between 108 MHz and 117.95 MHz with 50 kHz spacing. So Ottersberg would be 112.3 MHz. Then you have the three-letter VOR identifier, OTT, and next to that the Morse code, which is transmitted on the same frequency. So for Ottersberg VOR, it would sound like this. Now in the right hand corner of the box you sometimes see either a T, an A or H. These are different types of weather broadcasting facilities you can receive on the VOR frequency. This can be very helpful as the VOR is receivable at greater distances than most ATC frequencies. That's why you often see the voice button or tuning knob on the radio navigation panel. Now, depending on which app or chart you're using, the presentation of a VOR can vary a little. For example, ForeFlight doesn't have the box next to the VOR, but if you tap the station, you get all the important information you need. Jeppesen uses different symbol on the approach and departure charts. For example, a little D in the left-hand corner indicates a VOR with DME. So you see there are differences in presentation, but any app or chart comes with a legend which helps to clarify. Now, a common question by the FAA, are VORs aligned towards true north or magnetic north? Magnetic north, as you can clearly see on the compass rose around the VOR. If a VOR would point towards true north, it would always point in the same direction on the chart, as standard charts are orientated towards true north. But if you compare the Hay River VOR in northern Canada with a magnetic variation of 16 degrees and Ottersberg VOR with 3 degrees, you know VORs are aligned towards magnetic north. But actually the answer is both, because some of the VORs in the far north of Canada are aligned with true north, but that's a whole nother video right there. Okay, let's take a look on how it actually works, and I'll try to explain this as easy as possible. Now, the principle is very similar to a lighthouse. A lighthouse has a rotating light inside, flashing a Morse code so the sailor can write it down and determine his whereabouts. Now, at the same time, some lighthouses shine red and green colors, warning the sailor to not enter those areas due to cliffs or similar nature. A VOR works very much the same. Now picture two light bulbs, one white shining in all directions and a red directional light rotating around the white light. Now once the red light passes through magnetic north, the white light goes off for a second, then you start a timer and wait until you see the red light pass by and stop the timer again. Now if you know the rotation speed of the red light, let's say 60 seconds for 360 degrees, and you've just timed 20 seconds, that would mean 60 seconds equals 360 degrees. 20 seconds are how many degrees? 20 seconds times 360 degrees divided by 60 seconds equals 120 degrees. Piece of cake. Does that make sense? Obviously, a VOR doesn't emit any lights and you are not sitting there with a stopwatch, but your VOR receiver does that for you and projects that onto your CDI. So in our example, you are on a so-called radial 120. Now, what is a radial? Think of a VOR as a navigational device that's radiating 360 lines out of it. So whenever your instructor or ATC guy says fly radial 220, you immediately know you have to fly away from the station. So say to yourself, he wants me to fly radial 220 of Kempton VOR, so I have to radiate away from it. You can also think of each radial to be an individual laser beam emitting a line on the ground away from the VOR. Next step, how do I read my CDI and what can it do for me? Now the CDI is a course deviation indicator and most common in smaller general aviation airplanes. So let's take a closer look at this instrument. To the left or the right of the instrument, you have the OBS knob, the so-called Omni Bearing Selector. Now this enables you to turn or dial the requested radial you're supposed to fly or determine your location relative to the VOR by rotating the outer ring of the CDI. More on that on the next video though. Now in the middle, you have the CDI, the course deviation indicator, better known as the needle, which is hinged at the top of the instrument. Now think of the needle as an imaginary center line on a highway or a radial you have to follow. So if you were to be on the right side of the highway center line, your needle is to the left. So if you move towards the left, you approach the center of the highway, the needle moves to the center of the instrument. Now you are tracking along a radial. But if you continued left past the center, the needle would move past the center and move towards the right side. So you would have to correct to the right again. Does that make sense? So in flight, you navigate a radial by keeping the needle in the center, and if it moves to one side, you move towards it. So remember, fly towards the needle. But there's a little more to it if we, for example, fly towards the VOR and the OBS is set up incorrectly and you get reverse sensing. But more about that in the next video, where I also will show you how to determine your position relative to the VOR and how to intercept VOR radials and other VOR related maneuvers. But sadly, the era of the VORs is very slowly coming to an end as the global positioning system GPS gets more and more accurate for en route navigation and reliable enough even for approach procedures. But the DFS, the Deutsche Flugsicherung, aka the German Flight Safety, are spending a lot of money on maintaining and upgrading VORs. So for example, the VOR in the background used to be called Munich VOR, Mike Uniform November, but it was slightly outdated older VOR equipment and was recently updated to a more modern Doppler VOR. And more importantly, everyone is so dependent on GPS nowadays. Do you know who owns those 31 satellites? If that country decides to flick the switch and shut it all down, you better know how to navigate along a VOR radial. but more about that in the next video. A big thank you to the DFS for allowing me to fly with my drone over your VORs. I really appreciate the contact we've had and getting the permission for it. Thank you very much, you guys.